So let's start sorts. Okay. Sorts actually we're just going to have 5 types of compound that we're going to study in the 10th standard. Okay. And the properties, chemical properties is being asked in examinations. Okay. So let's discuss that each and everything. What are sorts? Sorts, you know very well that those compounds that are made up of when acid reactive basically become sorts. Okay. And the type of salt and the salts that are in our syllabus is the first one is NaOH. NaOH is not actually a salt, but we can consider this one as a compound. Since the preparation of this NaOH is means it is prepared from NaCl, a salt. That's why we study this one as a salt. Okay. This is caustic soda. Caustic soda. The second one in our syllabus is CaOCl2, that is bleaching powder. Bleaching powder. The third one is baking soda. Baking soda, that is NaHCO3. Fourth one is washing soda. Washing soda, that is Na2CO3.H2. And the fifth one is plaster of Paris. Plaster of Paris, that is CaSO4 dot half H2. Okay, you understood?
Yes, sir. Yes, sir.
First of all, let's start studying that is NaOH. Okay. Na is the caustic soda. But how caustic soda is prepared? Okay, let me explain you. As we take NaCl, concentrated solution of NaCl and water. Okay, everybody please turn on your camera. Share, turn on your camera. You just will find with that. Everybody please turn on your camera. Okay. Now I'm saying this is NaCl. NaCl when added to water, it forms brine. What it forms? Brine. Okay, brine. When brine is passed through ammonia gas, or when ammonia gas is passed through brine, it forms ammonical brine. It forms ammonical bond. You have to memorize each and everything, okay? Because we don't have much time to explain you each and everything. Okay. So what is ammonical brine? That's 1 marks question. Mixture of sodium chloride, NaCl, water and ammonia gas. When they are mixed together, they form ammonical brine. Ammonical brine. Okay. Ammonical brine. And when carbon dioxide is passed through this, they form sodium hydrogen carbonate as PPT. What does this arrow means? A solid substance and insoluble substance is formed. This is baking soda. I'm being let me explain to dear students because of subconscious mind I was teaching this one particular slide. I'm just teaching you right now the preparation of baking soda. Okay, we are just studying the baking soda. We will study the NaOH later. Okay, so this is baking soda is very important. So baking soda, let's study baking soda. So this is baking soda plus ammonium, baking soda and plus ammonium chloride is fine. Okay. Got it? So this is the preparation of baking soda. Okay, you understood? Understood everybody in the class?
Yes, sir.
Okay. Now, how baking soda is prepared? When we have NaCl, it is mixed with water and we pass ammonia gas to it, it forms ammonical brine. When ammonical brine is passed with carbon dioxide, it forms sodium hydrogen carbonate, which is soluble and which is insoluble. And we can say it forms PPT, and the ammonium chloride is settled down. Okay, ammonium chloride is, we can say that it is in aqueous. So we just filter the mixture. We have NaCl, sorry, NaHCO3, that is baking soda. This will settle down in the beaker or container. It will settle down. Okay, So this is sodium hydrogen carbonate, and the ammonium chloride will be in the dissolved. So it will be in the dissolved. Okay, in the dissolved. So this is an ammonium chloride. So we can separate this one, okay, by easy filtration. Okay, got it? Now you understood?
Yes, sir.
Yes, sir.
Now, how is, if I ask you a simple question, that how is baking soda, how is baking soda prepared? So you can write the preparation of this one. Okay, this is 1 marks question is being asked. And the process by which baking soda is prepared is called solvay process. This is called solvay process. Okay, this is called solvay process. You understood? Understood?
Yes.
Now you need to
Yes.
keep in mind that this baking soda, NaHCO3, that is called baking soda. Baking soda. It is the common name, but the chemical name is sodium hydrogen carbonate. Hydrogen carbonate. Okay. So if I ask you a simple thing here, that you need to keep in mind. If I ask you a simple thing, that what is the nature of this salt? Is it a acidic salt or a basic salt or a neutral salt? So sodium hydrogen carbonates, if I ask you that what are the parent acid of sodium hydrogen carbonate, so it is NaOH, or let it be. This I'm just directly saying that it is a basic salt. It is basic salt. Okay? It is a basic salt. Basic salt means it has some bitter taste. Bitter taste. Okay, it has some bitter taste. Now this sodium hydrogen carbonate, when we use this one for baking purpose, it is mixed with some edible acid. It is mixed with some edible acids. Edible acids. Okay. And what does edible acid will contain? It will contain some H plus ions. Okay. So we can say that this baking soda, when mixed with acid, so it forms baking powder. Baking powder. What is the difference between baking soda and baking powder? What is the difference between baking soda and baking powder? The difference between baking soda and baking powder is that baking powder is the mixture of baking soda and some edible acids. So we can write a definition here that what is baking powder? Baking powder. So we can say that it is the mixture of baking soda, that is sodium hydrogen carbonate, and some edible acid means weak acid that can be consumed. Edible acid such as tartaric acid. So this is now the question comes in your examination that what is the role of this baking? What is the role of this tartaric acid or edible acid? Why we are mixing this edible acid in baking soda to make it baking powder? So can anybody in the class answer me this question?
Can you repeat, sir?
I'm saying that why there is a need to mix edible acid with baking powder. Sorry, baking soda. Why we are mixing?
Baking powder.
Let me explain you. That this is sodium hydrogen carbonate. This is baking soda or baking powder. Tell me, what is it? Baking soda or baking powder?
Baking soda.
Soda.
Baking
Soda.
and it is mixed with some edible acid. That will give you what? It will give you baking powder.
Baking powder.
Baking powder. Now what happens when they are mixed together and they come in the contact with water? When they comes in aqueous, if this is in aqueous means in water. When we add this thing in water, what is going to happen? Means when you have a mixture of both baking soda and acid, you add it to water, the chemical reaction will start. What is this chemical reaction? What is this about? What is this chemical reaction? You know that this is what? Metal hydrogen carbonate and this is acid. So what happens when metal hydrogen carbonate react with acid? Metal hydrogen carbonate react with acid. What happens? What happens when metal hydrogen carbonate that we have studied react with acid? Carbonate plus acid, it will give you salt plus carbon dioxide plus water. Okay, here carbon dioxide will be produced. You understood?
Yes,
Adil
sir.
and Tejasvi, why you have turned off your camera?
Sir, because of Lect.
Okay. Now what would happen here? This is now you understand? What is going to happen here? Now you are going to have sodium hydrogen carbonate. This is baking soda. When you add it with acid, it will produce some salt because this is metal hydrogen carbonate plus water plus carbon dioxide. You can write this thing here or this thing here. It's okay. Carbon dioxide is produced. And what is the role of this carbon dioxide? This carbon dioxide help in making the bread fluffy. Now assume that you are having a dough of of food, or you add baking soda, you add baking powder to it. Baking powder. When baking powder is sodium hydrogen carbonate plus a double acid. Okay. So this is sodium hydrogen carbonate when react with double acid. And when you add in water, the reaction will start. And when the reaction will start, what is going to happen? The carbon dioxide is produced because sodium hydrogen carbonate is metal hydrogen carbonate, and this is acid. When metal hydrogen carbonate react with acid, they produce carbon dioxide. So here the carbon dioxide will produce and it will get trapped in the size of the dough will increases because of this extra carbon dioxide. Okay. Carbon dioxide. This will trap in the holes of this dough. What would happen when you put this in the oven? This carbon dioxide molecules or gas will be escaped out due to heating, and you will see like the breads have holes in it. But why it is due? Because they are initially when we were preparing, the carbon dioxide was trapped in it, but when we kept it in the oven, due to heat, the carbon dioxide escape and the holes remains. Okay, that makes the bread fluffy. Okay, so it help. What is the role of edible acid? If there is no acid, no carbon dioxide will be produced. It help in the formation of carbon dioxide or liberation of carbon dioxide, which help in making the bread or dough fluffy, which is used for baking purpose because it is baking soda. And moreover, you know this sodium hydrogen carbonate is a basic salt. It is a basic salt. Basic salt because it is a salt of strong acid and weak base. Sorry, strong base and weak acid. Okay. So this is a basic salt. When it reacts with acid, so it also neutralizes the bitter taste. Basic salt means it is having some basic nature. Base when react with acid, it gives you salt. So it will neutralize it. When acid react with base, it will neutralize it. So it has bitter taste due to its basic nature because it is a basic salt of a strong acid and weak, strong base and weak acid. Strong base and weak acid, like NaOH is a strong base. When it reacts with weak acid, H2CO3, it will give you NaHCO3. That's what. So this is a basic salt. Basic salt. So when we add acid to it, so it will neutralize its bitter taste. It will not give the bitter taste to the food. Okay, Adil, you are understood?
Yes, sir.
Yes, sir.
Okay. So let's write each and everything. What is the role of tartaric acid in preparation? Note this, please. Baking soda prepared by solver process. Note it fast. Do it, please.
Done, sir.
Shoaib, are you writing?
Yes, sir.
The camera is only showing your head. Face is not.
Ooh.
Done, sir.
Yes, sir. Done.
Note down this one. That what is the role of edible acid in baking powder? It help in the production of. Note it down. Done. Noted that it help in the production of what? Role of edible acid. That In the baking powder, that it help in the production of carbon dioxide, which help in making the bread fluffy in baking industries. It neutralizes the bitter taste of baking soda, NaCO3, as it is a basic salt.
Done, sir.
Done. Okay. Soda acid fire extinguisher is also, it means it is also this sodium. They means you can say that what is the use of this baking soda? Okay, baking soda, baking. Okay, so what is the use of this baking soda? One, it is used for baking purpose, and second one, it is used in soda acid fire extinguisher. Okay. This is the soda acid fire extinguisher in which there is a bottle, okay, of H2SO4, and in the bottom we have baking soda NaCO3. Okay, and when we pin this one, this bottle break and the acid comes in the contact with this one, react with this one. So this reaction takes place. NaCO3, this is metal hydrogen carbonate, when react with acids, it will give you salt plus water plus carbon dioxide. Okay. So since carbon dioxide is produced instantly and carbon dioxide is being used for as a fire extinguisher. Okay, because carbon dioxide, the mass of carbon dioxide is 44 and the mass of oxygen is 32. So since carbon dioxide is heavier than oxygen, so this carbon dioxide gas comes at the lower, or we can say it will replace the oxygen from the fire and the fire get extinguished. Okay, so this is the reason that why soda acid fire extinguisher is used, or why baking soda is used in fire extinguisher, because it reacts with acid, it gives you carbon dioxide, and this carbon dioxide help in the how does it help? Tell me, Adil, are you getting? Adil, are you there? Adil or Adil? Are you there? You are muted. Okay, so it help in noted this one. So note this reaction and why it is used. Okay, noted this. Note this one. Why baking soda is used as soda acid and soda acid fire extinguisher. Note this equations and write down. Simple. Write the hints only. Okay. Till here you have to write. Don't write this. And write on reaction with acid, it produce carbon dioxide, which will help in the extinguishing of fire. Okay.
Done, sir.
Done, sir.
Okay. So if the question comes in examination that for making baking powder, for making cake, baking powder is taken. Baking powder is taken. If at home your mother uses baking soda instead of baking powder, if at home your mother uses baking soda instead of baking powder, how will it affect the taste of the cake and why? So you know that if instead of baking soda, baking powder, only baking soda is used, so it will give a better taste to the food. Why? Because it is a basic salt.
Yes.
And moreover, less amount of carbon dioxide will be produced, or we can say the bread will not become fluffy, or the food pakoda will not become fluffy. Okay. The first case is that the taste will be bitter. Bitter taste. Okay. And the second one will be it will gives you if you alone heat sodium hydrogen carbonate, let's suppose if you heat sodium hydrogen carbonate alone, that will gives you Na2CO3 plus carbon dioxide plus what, and it will gives you more bitter taste because this is more bitter than this one. Still it has hydrogen but does not have any hydrogen, that does not have any acidic weight, so it will gives you more bitter taste. Okay, so if you use bad quality of baking soda or baking powder which is not containing a double acid, so this will gives you bitter taste to the food that we are looking. So it will affect the oil. So it will gives you bitter taste. And how can baking soda be converted into baking powder? By adding a small amount of tartaric acid. And what is the role of tartaric acid? That we have written this all three. Okay. Now you understood? So
Yes, sir.
if the question comes, you will be able to answer this question. Okay. Now let's move further. Let's talk about the very important, that is NaOH, caustic soda. And what is caustic soda and how caustic soda is prepared? Okay. Caustic soda, that is NaOH. It is caustic soda. And it is, we can simply say that it is NaOH. It is called sodium hydroxide. This is the common name, caustic soda, but the chemical name is sodium hydroxide. Okay, this is sodium hydroxide, and this is this is chemical name. Okay. Now, how it is prepared? When we have a concentrated solution, not the dilute solution, concentrated solution of NaOH in water. It should be concentrated brine. Concentrated means because the solution is concentrated, large amount of NaOH is being dissolved in water. Okay, and moreover, brine, white brine, because brine is the mixture of NaOH and water. Okay, so when we pass electricity to it, then it will gives you NaOH plus hydrogen gas plus chlorine gas. Chlorine is negative, you know, Cl minus, chlorine is negatively charged. So it will form at anode. Negative these ions, anions goes negative charge goes to the positive rod. So anode is positive. Hydrogen is positively charged. So it will goes at cathode. Cathode is negatively charged. And this will form near anode. Sorry, near cathode. Okay. And the process by which this is formed, it is called chlor-alkali process. It is called chlor-alkali process. Okay, chlor-alkali process. Why it is called chlor-alkali? Because chlor means this is chlorine gas. This chlorine gas is formed, and NaOH is alkali. This is soluble base. NaOH is alkali. Okay, alkali means soluble base. Okay, so this is the preparation. Note it down. Note till here, and we will write why it is called chlor-alkali process. Note it down till here. Electricity.
Done, sir.
Done. Sure.
Yes, sir.
Okay. Done, everybody. Should I move next?
1 minute, sir.
Okay.
Done, sir.
Done. Now, moving to this portion. Note this one, please. This process is known as chloralkali process. Due to the formation of chlorine gas and NaOH. Chlorine gas is chlor, indicating chlor, and NaOH indicating what? NaOH indicate alkali. Okay, so that's why it is considered to be as chloralkali process. Done?
Yes, sir.
Okay.
Yes.
Now note it down that physical properties of NaOH, that is just white, translucent, lucent, melting point is 591 Kelvin, readily soluble in water, means it is not exact, is spontaneously soluble. Readily means just it can dissolve. Deliquescent means absorb moisture from atmosphere. When it is kept for a long time, it get converted, means it react with atmospheric carbon dioxide and form sodium carbonate in water. And are down the uses also. Adil, are you there?
Yes, sir.
Done?
Sir.
Done, sir.
Next one is bleaching powder. Shape, where have you gone?
Yes, sir.
Turn on your camera. Shweta, you also. So if I'm talking about this bleaching powder, okay. So bleaching powder is calcium oxychloride, and that is it is called calcium oxychloride or calcium hypochlorite. This is one marks question being asked so many times in the examination, that what is the common name of bleaching, chemical name of bleaching powder. So that is calcium oxychloride or calcium hypochlorite. Okay, and how it is prepared? It is prepared when slaked lime. Just listen to me. Then slaked lime, calcium hydroxide is slaked lime. When chlorine gas is passed through this one, it will give you calcium oxychloride plus plus water plus plus water. Okay. What would happen when this calcium oxychloride react with this one? So it is, sorry, slag lime. Okay, slag lime and lime water has same formula. Slag lime is, we can say that slag lime is calcium hydroxide. This slag lime. This is slag lime. And lime water, this is also calcium hydroxide. Lime water. They have both same formula, but what is the difference? That it is aqueous form in water, but it is solid form. Solid means approximately means it is paste-like structures, like we have toothpaste, okay? And it is just like sugar solution, like we have, okay? This is a solution, and this is a paste-like structure, okay? Dry, you can say that, okay? So when slag lime is passed with chlorine gas, it forms calcium oxychloride, that is bleaching powder, and water, okay? You understood?
Yes,
Understood?
sir.
Yes, sir.
So what would happen when
Yes,
in the,
sir.
during the preparation of this one? That this is bleaching powder, sorry, slag lime when react with chlorine gas, it will form the calcium oxychloride plus water. And this process of formation of bleaching powder is called Hazen-Claver process. Note it down. Note it down fast. Done? Note it fast.
Yes, sir. Done.
What is the property of calcium oxychloride or bleaching powder? It is yellowish white powder with a strong smell of chlorine. Now, keep in mind that so many times it will be asked a compound X with a strong smell of chlorine. So what does it mean? It means bleaching powder. Okay. When it is exposed to air, so it will react again with carbon dioxide. Let me explain you that when bleaching powder is kept in open air, it will react with atmospheric carbon dioxide and form calcium carbonate plus this will react with this one and this chlorine gas will be released. So when the bleaching powder is when there is no chlorine in bleaching powder, it will be of no use. Means it will not show any property of bleaching. Okay. So bleaching action is done by chlorine. So if you kept it in open air, it will be no use. So to avoid this, we just kept this bleaching powder in airtight container. Where we kept it? We keep it in airtight container. Okay. Note it down. Why bleaching powder is kept in open air? Because it reacts with the atmospheric carbon dioxide and it will form calcium carbonate and chlorine gas. Okay. So to avoid this, we just keep it. So note it down. Done?
Yes, sir.
Now, uses of bleaching powder, note it down.
Done, sir.
Now, here's the question. Note this question, please. And everybody, this one. So note this question. A compound X on electrolysis solution produces a strong base Y and two gases A and B. B is used in the manufacturing of bleaching powder. Identify X, Y, A, B, and write the chemical reactions. Write down the question first. Noted? What is saying? A compound X on electrolysis gives a strong base. So what can be compound X? Compound X on electrolysis in aqueous, in water, gives a strong base. So what can be X, Tejasvi?
Chloride.
Sodium chloride.
Yes, it can be sodium chloride when react with water on electrolysis. Okay, electricity. So it will gives you what? It will gives you NaOH. It's a strong base. Why?
CH2, H2.
X plus chlorine gas plus hydrogen gas. Okay. A gas along with two gases, A and B. B is used in manufacturing of bleaching powder. So which gas is used in bleaching powder?
Hydrogen and chlorine.
Hydrogen is used in bleaching powder. Check the preparation of bleaching powder in your copy. Which gas is passed through slag lamina?
Chlorine gas.
Yes, chlorine gas. So this is B gas is chlorine. Now this will be A. So what is A? What is X, Y, B, and A? You understood? Okay.
Yes, sir.
Otherwise, some students may write this gas as A. So you need to keep in mind that A is hydrogen gas because hydrogen is not used as in bleaching powder. Okay, B is used as bleaching powder. Got it? It's chlorine gas. Understood?
Yes,
Yes,
sir.
sir.
Note this question in your copy first. A metal carbonate X. Note this question fast. Noted?
Yes, sir.
Yes, sir. Done.
Okay, now on the information that we have studied till yet, let's do this one. Okay. So a metal carbonate X on reacting with acids. A metal carbonate, there is a metal carbonate. Okay. Now, there is a metal carbonate X on reacting with acid gives a gas. So this is metal carbonate. Okay, metal carbonate, metal carbonate. When react with acids, what it will gives you?
Salt plus
Salt plus water plus
Mm.
carbon dioxide. So gives a gas which when passed through a solution Y, there is solution Y. This is a gas. It is passing with a solution Y, and this is metal carbonate X. Okay, gives the carbonate back, means give this back. Okay, so this is again X is obtained here. Okay, we still have no idea that what is X, what is Y. Okay, now on the other hand, a gas G is obtained at anode. Now, just look at this. You have now your knowledge will be used here. On the other hand, a gas G is obtained at anode on electrolysis of brine. What is brine? NaOH plus
plus
water. It is NaOH on electrolysis. Electricity passing through this, you will get NaOH plus Cl2 plus H2. Which gas is produced at anode? Check your notes. We have done this.
Cl2.
Cl2 is obtained. On the other hand, a gas G is obtained at anode. So this is gas G. Okay, this is gas G right here. Gas G. Okay, and during the electrolysis of compound, okay, at anode during the electrolysis of brine. If passed on dry Y, now this gas is passed on dry Y. Okay, now keeping your knowledge, what? Okay, so gives a compound Z. Now, when this gas G is passed through dry Y, this is solution. Now, this is dry Y. dry. Why? When it is passed through this one, gives a solution, gives a substance which is used for disinfecting, gives a compound Z, and this is used for disinfecting for killing germs. Which compound is used as for killing germs?
Bleaching powder.
Yes, bleaching powder is used. So you will write here calcium oxychloride is used for killing germs that you have noted. So this one is Z compound. And through which compound does chlorine gas is passed to get bleaching powder? To which compound? It is calcium hydroxide, calcium slake lime. Slake lime, okay. Dry lime means slake lime. And the solution of this is called lime water. Calcium oxychloride. This calcium hydroxide, this is why. Okay. And since this is a calcium is obtained here, so this will be a salt of calcium carbonate. So this is calcium carbonate. Because metal carbonate, calcium we are having. Okay. So you can simply say that gives the metal carbonate back. It means this metal carbonate is means here you will obtain calcium carbonate. Because when calcium hydroxide is passed with carbon dioxide is passed through calcium hydroxide, it will gives you calcium carbonate, CaCO3. Okay, so X is CaCO3. X is CaCO3. Y is CaOH whole twice. G is chlorine gas, and Z is bleaching powder. Note it down. Note all the reactions.
Done, sir.
Done?
Yes, sir.
Yes, sir.
Now do this one. Note this question. Fast. Note this question. So have you noted? Alvina, wait for 2 minutes. Okay, just finishing this. So have you noted, dear students, this one? A dry pellet of
Yes.
common base,
Yes, sir.
B. Dry pellet of common base. So common base is NaOH. Kept in open, absorb the moisture. In terms of sticky, because it absorb the moisture. You know that this is deliquescent salts, and we have written this in the notes. And is also a byproduct of chloralkali process. Means a common base can be generally common base can be KOH or NaOH. But when it says the byproduct of chloralkali process, so it means it is NaOH. Confirm. Okay. Got it? Common base, that is a byproduct of chloralkali process, that is NaOH. Identify B. What is B? So B is NaOH. What type of reactions occurs when B is treated with acetic oxide? So what is acetic oxide? Non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. Okay. Got it? So when you treat it with acetic oxide, so you know this is base and this is acid. That will give you salt and water. So what it will give you, tell me? It will give you sodium carbonate and into CO3. That's water, okay? And I type balanced chemical equation, you can write it. So that's all for today. We'll meet you in the next class, okay?